Imagine a single sunspot so large it could swallow Earth whole. This isn't just a hypothetical scenario, it's a reality that astronomers have observed. That's how 2024 began, with a clear sign that our sun was stirring from its slumber. The appearance of such a massive sunspot was a wake-up call, signaling the start of a new solar cycle. This colossal sunspot, a dark blemish on the sun's surface, heralded the approach of a period scientists call solar maximum. During this time, the sun's activity ramps up significantly. Like a celestial pendulum, the sun swings between periods of relative calm and heightened activity. This rhythmic dance is a natural part of the sun's life cycle. This cycle, marked by the ebb and flow of sunspots, eruptions and solar flares, governs the very space weather we experience here on Earth. These solar events can have profound effects on our planet. Sunspots, cooler regions on the sun's surface, are windows into the sun's churning magnetic field. They offer scientists valuable insights into the inner workings of our star. Their increased presence signals a surge in the sun's internal dynamo, leading to more frequent and powerful solar events. This surge is a precursor to the dramatic displays of solar power we are about to witness. As we enter this solar maximum, we brace ourselves for the sun's fiery breath to reach out across millions of miles, carrying with it both the promise of celestial wonders and the threat of technological disruption. The impact on our satellites, power grids, and communication systems could be significant. Fasten your seatbelts, space travelers, because the sun is about to put on a show. The upcoming solar maximum promises to be a spectacular and potentially challenging time for all of us. The sun isn't a static ball of fire. It's a dynamic, ever-changing celestial body, constantly in motion and full of surprises. Deep within its core, a nuclear furnace churns, generating immense energy that powers the sun and bathes our solar system in light and warmth. This energy is the lifeblood of our solar system, providing the necessary heat and light for life on Earth. This internal energy also drives the sun's magnetic field, a force that extends far out into space, forming what we call the heliosphere. The heliosphere acts as a protective bubble, shielding our solar system from cosmic radiation. This magnetic field isn't content to sit still. It is in a constant state of flux, always changing and evolving. Every 11 years or so, the sun's magnetic poles flip, north becoming south and south becoming north. This phenomenon is known as the solar cycle. This flip isn't a sudden switch, it's a gradual process that unfolds over years, culminating in a period of peak activity known as solar maximum. During this time, the sun is at its most active, with increased sunspots and solar storms. During this time, the sun's magnetic field lines become tangled and twisted, like a rubber band stretched to its limit. This tension can lead to dramatic solar events. This tension builds until it's finally released in spectacular bursts of energy, solar flares, and coronal mass ejections. These eruptions can have significant effects on space weather. These events can hurl massive amounts of charged particles, known as solar wind, towards Earth at incredible speeds. When these particles interact with Earth's magnetic field, they can create stunning auroras and even disrupt satellite communications. While the sun sustains life on Earth, its outbursts can also pose significant threats. When a powerful solar storm erupts, directing its energy towards our planet, we feel the effects in various ways. One of the most direct impacts is on our technological infrastructure. Solar storms can disrupt radio communications, knock out satellites, and even cause power outages on the ground. A powerful solar storm slammed into Earth, causing a widespread power outage that plunged millions into darkness. This event served as a stark reminder of our vulnerability to the sun's temperamental nature. And as our world becomes increasingly reliant on technology, the potential consequences of a major solar storm grow even more significant. From GPS navigation to financial transactions, countless aspects of modern life depend on satellites and communication networks that are susceptible to solar interference. In 1859, the world witnessed the most intense solar storm in recorded history, the Carrington event. Named after Richard Carrington, the astronomer who observed the solar flare that triggered it, this event serves as a stark reminder of the sun's awesome power. Back then, our technological dependence was minimal. Telegraph systems, the cutting edge of communication at the time, went haywire, sparking fires and delivering shocks to operators. But imagine the consequences if a Carrington-level event were to occur today. The damage to our power grids, communication systems, and satellites would be catastrophic, potentially crippling global economies and disrupting everyday life for months, if not years. Scientists estimate that such an event could cost trillions of dollars in damage and take years to recover from, highlighting the urgent need for better space weather forecasting and mitigation strategies. As we venture further into the digital age, our reliance on technology only deepens. Satellites, the unsung heroes of modern communication, orbit Earth, facilitating everything from GPS navigation to television broadcasts. But these technological marvels are incredibly vulnerable to the ravages of space weather. The solar wind, a constant stream of charged particles emanating from the sun, intensifies during solar maximum. This barrage of energy can disrupt satellite operations, degrade signals, and even shorten their lifespan. In extreme cases, it can lead to complete satellite failure, plunging us into a world without the technologies we often take for granted. Imagine a world without GPS, accurate weather forecasts, or even reliable internet access, a stark reminder of our interconnectedness with the sun's every whim. The sun's influence extends far beyond our technological systems. It plays a crucial role in shaping Earth's climate. While the sun provides the energy that drives our planet's weather patterns, the relationship between solar activity and climate change is complex and not fully understood. Some studies suggest that increased solar activity during solar maximum could lead to a slight warming effect on Earth. However, this effect is dwarfed by the much larger impact of human-caused greenhouse gas emissions, which are the primary driver of the current climate crisis. The sun's natural cycles, including solar maximum, are not responsible for the rapid warming trend our planet is experiencing. It's essential to distinguish between natural variations in solar activity and the long-term changes caused by human activities. Amidst the potential disruptions, solar maximum also brings with it a breathtaking spectacle: the aurora borealis and aurora australis, more commonly known as the northern and southern lights. As charged particles from the sun collide with atoms in Earth's atmosphere, they excite these atoms, causing them to glow in vibrant hues of green, red, blue, and purple. During solar maximum, these celestial displays become more frequent and intense, reaching latitudes further from the poles. Imagine gazing up at the night sky, witnessing curtains of shimmering light dancing across the heavens, a mesmerizing reminder of the awe-inspiring forces at play in our universe. So, while we prepare for the potential challenges of solar maximum, let's not forget to marvel at the celestial wonders it brings. As we enter this period of heightened solar activity, it's crucial to approach it with a sense of both wonder and caution. The sun, our closest star, is entering a phase known as the solar maximum, where its activity peaks and solar flares become more frequent and intense. The sun, our life-giving star, is a force of immense power, capable of both nurturing and disrupting our technological civilization. Its solar flares and coronal mass ejections can have profound effects on our planet, impacting everything from satellite communications to power grids. By understanding the risks and preparing for potential impacts, we can mitigate the challenges and embrace the opportunities this solar maximum presents. Scientists and engineers are working tirelessly to develop new technologies and strategies to protect our infrastructure and ensure the continuity of our daily lives. Space weather forecasting plays a vital role in this endeavor. By predicting solar storms and their potential impacts, we can take proactive measures to safeguard our technology and infrastructure. Just as we monitor terrestrial weather patterns, keeping a watchful eye on the sun's activity allows us to anticipate and prepare for potential solar storms. This vigilance helps us minimize disruptions and maintain the functionality of our critical systems. By hardening our infrastructure, developing backup systems, and improving our forecasting capabilities, we can navigate the challenges of solar maximum and harness the sun's power responsibly. These efforts not only protect our technology but also pave the way for future advancements in space weather science. This is a time for scientific exploration, technological innovation, and a renewed appreciation for our place within the sun's dynamic and ever-changing domain. As we continue to study and understand our star, we gain valuable insights that benefit not only our planet, but also our future endeavors in space exploration.